Hello, this is Wei again from Xi'an Power Company. Today we're going to introduce our voltage solutions for the voltage sag and swell, which is our AVC product, in short of active voltage conditioner. Now, this is a typical waveform of the voltage. You can see it's a sine wave and it's continuously, and the amplifier is stable. And for your load, so it can keep your load works continuously and stable. Imagine that the situation for some kind of the production line is running smoothly and continuously, but if the voltage has fluctuation or sag or swell, may affect the equipment on site, so will cause the stop or inject or stuck of your production line. So this is why we need a stable and smooth voltage curve on the site. And this is a typical voltage sag for the voltage waveform. And you can see from here, the normal voltage is like this, but when the sag is coming, the amplitude of this waveform is lower than the normal voltage. And in this situation, because the voltage drop, your equipment will not work as a regular situation. And to define the voltage sag, we have to know how far the voltage falls, meaning how deep the voltage sag is, and how long the events will last. And this one is a typical waveform of the voltage swell. You can see the amplitude of the voltage waveform is higher than the standard one. So it also may cause the damage on your equipment, such as some sensitive to the voltage. We can define this a temporary rise in RMS voltage increase. The sag and swell will also cause the malfunction on your production line. And that's why we bring the AVC to make sure the voltage on your load will be continuously and smoothly. The incoming voltage of the grid will get a fluctuation, like will be sag or the swell. So our solution will solve this kind of situation. We can make sure during the sag and swell, we can make the load voltage as we set, we'll make it stable and smooth. And for our Kobe Power's AVC can support maximum at 30% positive or negative sag and swell. And this is our SRD of our AVC here. And the AVC work is like this. First, we're going to monitor the incoming voltage. And if the AVC detect voltage sag and swell, and this time our AVC we're going to compensate for the voltage, which means we're going to generate a difference voltage to compensate for the sag or the swell. And the final result will be like this. We're going to stabilize the load voltage to your end user. Will be look like the voltage of all the load will be stabilized and will be continuous and stable. And our AVC has mainly 4 parts, and it's working like this. First part is the AVC bus modules. Second part is the AVC sleeve modules. Third part is the bypass switch modules, which can bypass the AVC when there is a malfunction inside the cabinet. And the fourth part will be the series coupled transformer. This transformer is a little bit different to traditional transformers, which is the secondary side of this transformer is in series between load and grid. And the primary side of this transformer is in parallel of the output of the AVC slave modules. So we're going to work like this. At the beginning, the AVC mass module converts the AC and voltage to the DC voltage. And the AVC slave module, we're going to convert the DC voltage to the AC voltage and output the AC voltage. Therefore, the primary side will be there will be an input voltage for the primary side of this transformer. And therefore, there will also be a voltage on the secondary side of transformer. And also because the original grid side voltage also goes to the secondary side of this transformer. So the original voltage and our voltage we inject or minus the voltage we inject. This is how we do the voltage compensation. We add or minus a voltage through these transformers. So the final result we're going to be like this. If you have a swell, we are going to give you more amplitude and same phase angle voltage to make it to a standard voltage. And if you have a voltage swell, we're going to give you a reverse voltage to minus the voltage to make it to the standard voltage levels. So through the introduction, we can see we only compensate the voltage differences here. We do not compensate for the all the load in the working time. So that's why the AVC can only compensate for the 30% second swell, because we have to get the energy from the grid side. If the voltage is too low, will make the AVC cannot work on its own. That's why we have to have the limits of the AVCs. And since we get the energy from the grid side and it can work continuously. This is how AVC works. And since we have to compensate the differences between the standard voltage and the voltage cycle swell, we don't have to put all the energy as the load need. We only have to output the differences between the load need and what we output. So this will make AVC can compensate the higher capacity than the AVC capacity its own. Such as if you have a 100 kVA load and there is a 30% voltage drop on your side, it will be like this. The AVC sizing will be like this. You use 100 kVA times to a 30% voltage drop, meaning you have to need the AVC capacity you will need is 30 kVA. So the AVC only compensates for these differences. And this is the Koei Power's AVCs here. And this is our indoor modules. We also can customize outdoor modules. For our AVC, here the code performance will be like this. The response time is less than 20 milliseconds. And the output voltage accuracy is less than 1%. It's very accurate. And the efficiency of the whole cabinet will higher than 98%, and it can compensate for the continuously second swell minus or positive or negative 30%. Also, we have some customized option, which will be the single phase, the different protection levels, the Modbus TCP communication, the Wi-Fi or the Ethernet. And also because we have AVC module is in parallel of the whole system, we can compensate for the reactive, harmonic, and current unbalanced as well. This is the introduction of the AVC here. And if you have any question or you have already mapped the problem like this on your site or some project like this, feel free to contact us. This is a sales Koei Power. This is our email address. Bye.